Hello, myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss about Fourier series. So the definition of Fourier series is Fourier series corresponding to a function fx in an interval minus t less than equal to x less than equal to t under certain condition is the trigonometric series of the form a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by t plus bn sin n pi x by t, where a0 an bn are called Fourier constants or Fourier coefficients or Fourier coefficients. They were applied by the French mathematician J.B.J. Fourier to the study of heat conduction. Okay. So to indicate a Fourier series of a function fx, we write like this: fx is approximately equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by t plus bn sin n pi x by t. Okay. Now how can we find a0n and bn? So a0 will be equal to 1 by t minus t to t fx dx, an equal to 1 by t minus t to t fx cos n pi x by t dx, and bn equal to 1 by t minus t to t fx sin n pi x by t dx. Okay, so this an is called Fourier cosine constant and bn is called Fourier sine constant. Okay, so an is called Fourier cosine constant, bn is called Fourier sine constant. So now we have defined it for the interval minus t to t, if fx is defined on minus t to t. Now I will define this Fourier series for another type of interval. If fx is defined in C to C plus 2t, C to C plus 2t, and fx is a periodic function of 2t, and fx is a periodic function of time period 2t. Then Fourier series of fx will be a0 by 2 plus summation n equal to 1 to infinity n cos n pi x by t plus bn sin n pi x by t, where a0 will be 1 by t c to c plus 2t fx dx, and an will be 1 by t c to c plus 2t fx cos n pi x by t dx, and bn will be 1 by t c to c plus 2t fx sin n pi x by t dx. Okay, so this was the definition of Fourier series on the if the function is defined on the interval c to c plus 2t. Now there are another type of Fourier series that's called half range series. Half range series. There are two types of half range series. One is called Fourier sine series, Fourier sine series, and another is Fourier cosine series. Okay, so why this type of series is called half range series? Because minus t to t, the previous definition was defined if the function is defined on the interval minus t to t. Now the function will be defined on the interval 0 to t. So if fx is now how can we obtain this half range series? Okay, so from the basic definition, main definition of Fourier series, we can obtain the half range series depending upon the types of the function, that is the function is even or odd or neither even nor odd. Okay, so one by one I will discuss. Number one, case number one, if suppose fx is odd function. Okay, so if fx is odd means f of minus x will be minus of fx. So the formula of a0 was 1 by t minus t to t fx dx. Now since fx is odd, this value will be 0. Okay, now an was 1 by t minus t to t fx cos n pi x by t dx. Now since fx is odd and cos is even, the product of odd and even function is always odd function, so this is also 0. Now bn is 1 by t minus t to t fx sin n pi x by t dx. Okay, now fx is odd, sine is odd function, so product of two odd function is always even function, so it can be written as 2 by t 0 to t fx sin n pi x by t dx. Okay, so here we can see that if fx is odd function, then a0 and an are both 0. Then the Fourier series becomes since a0 and an are 0, so this will be summation n equal to 1 to infinity bn sin n pi x by t, where bn is 2 by t 0 to t fx sin n pi x by t. dx. Okay, so this series is called Fourier sine series. This series is called Fourier sine series. Okay. Now the next case I will discuss if the function is even function. So if the function is even function, then f of minus x is equal to fx, and a0 is this, the definition of a0. So this can be written as 2 by t 0 to t fx dx. An will be, since fx is even, cos is even, product of two even function is always even, so this will be 2 by t 0 to t fx cos n pi x by t dx. And bn, fx is even, sine is odd, product of even and odd function will be odd function, so this will be 0. So the Fourier series corresponding to this even function will be a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by t, where a0 is this and an is this. This series is called Fourier cosine series. Okay, Fourier cosine series. Now there is a theorem called Dirichlet's condition. So for the existence of Fourier series of a function, now I will tell you that conditions, those conditions called Dirichlet's conditions. Dirichlet's conditions. Okay. So a function fx defined on minus t to t is said to satisfy Dirichlet's condition. Dirichlet's conditions if it satisfies any one of the following two conditions. So the two conditions are: number one, fx is bounded. Fx is bounded in the interval, closed interval minus t to t, and the interval minus t to t can be decomposed into a finite number of subintervals, such that fx is monotonic, increasing or decreasing on each of the subintervals, And number two, condition number two, fx has a finite number of points. Fx has a finite number of points of infinite discontinuity, in the interval, closed interval minus t to t. So when arbitrary small neighborhoods of these points are excluded, fx is bounded in the remainder of the intervals, and this can be broken into a finite number of open partial intervals. Open partial intervals in each of which fx is monotonic further the improper integral minus pi to pi fx dx is to be absolutely convergent. Okay. Now, okay. First, I remove this. When fx satisfies Dirichlet's condition, Dirichlet's conditions on the interval minus t to t, close interval minus t to t, Fourier series of fx converges to fx. Fourier series of fx converges to fx. Okay. At any point of the interval minus t to t. Okay, this will be open interval minus t to t. When fx is continuous, and converges to half f of x plus 0 plus f of x minus 0. There is an ordinary discontinuity. There is an ordinary discontinuity at the point. In particular, x equal to t and x equal to minus t. It converges to half into f of minus t plus 0 plus f of t minus 0. Okay. Now I will state a very important theorem. just a statement will be required for you. A statement, write the statement. Theorem is, if a function fx is defined on close interval minus t to t satisfies Dirichlet's condition, then its Fourier series is convergent and the Fourier series a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by t plus bn sin n pi x by t equal to fx, if x is the point of continuity, if x is the point of continuity, and this is equal to fx if x is the point of continuity, and this will be equal to half into limit t tends to x plus ft plus limit t tends to x minus ft if x is the point of ordinary discontinuity. Okay, and this will be equal to half into limit t tends to t plus ft plus limit t tends to t minus ft at x equal to plus minus t. So this theorem is very important for Fourier series. Now I'll go to the next topic, that is called Parseval's identity. This is also very important. Parseval's identity. If the Fourier series of a function, if the Fourier series of a function fx converges uniformly to fx in the interval minus t to t, then 1 by t integration minus t to t fx whole square dx is equal to a0 square by 2 plus summation n equal to 1 to infinity an square plus bn square, where an and bn are Fourier coefficients of fx. Now next theorem is statement is any function can be expressed as the sum of an even and odd function. Even and an odd function. Proof. Let fx equal to half into fx plus f of minus x plus half into fx minus f of minus x. Okay, and let us name it as gx and this as hx, where gx is this and hx is this. Okay, so if gx is this, then g of minus x will be half into f of minus x plus f of x, which is equal to gx. So gx is an even function. Okay, now h of minus x is half into f of minus x minus f of x, which is equal to minus of hx. So this is an odd function, hx is an odd function, hence gx is even and hx is odd. So the function is expressed, this function has been expressed into the sum of an even function and an odd function. Okay. Now I'll solve some problems of Fourier series. So okay, so you have to find the Fourier series. You have to find the Fourier series of fx equal to x square defined on the interval minus pi to pi, and after that you have to find the value of some series, infinite series. I'll write it later. First I will find the Fourier series of this function defined on this interval minus pi to pi. So first we see that this function x square is an even function. So if the function is even, then we know that the Fourier series will come, that will be Fourier cosine series, half range series. So a0 will be 1 by t is here pi, and minus pi to pi x square dx, and since x square is an even function, so this will be 2 by pi 0 to pi x square dx. So this will be 2 by pi x cube by 3 0 to pi. So 2 by pi into pi cube by 3, and that is 2 pi square by 3. So this is the value of a0. Now we'll go to an. So an, the formula of an is 1 by pi minus pi to pi fx, that is here fx is x square cos n pi x by t dx, and here x square is an even function and cos is an even function, so the whole function is an even function, so we can write it as 2 by pi 0 to pi x square cos, sorry, this will be pi, t, the value of t is pi, so this will be cos nx dx. Okay, now we have to integrate this by applying bypass integration. So 2 by pi is constant, first function is x square, integration of second, that is n sin nx, 0 to pi minus 2n integration 0 to pi x sine, sorry, this will be by n, we are integrating, this will be 2 by n sine nx dx. Okay, now 2 by pi x square by n sine nx 0 to pi minus 2 by n, and first function is x, and this will be minus cos nx by n minus differentiation of first function, that will be 1, and after integrating this will be minus cos, so this will be plus, and again we are integrating cos, so this will be sine nx by n square. Okay, so this is also 0 to pi. Now if we put the limits for pi, sin n pi is 0, this will be 0, minus for x equal to 0, this will be 0, minus 2 by n. For pi, this is plus, so 2 by n square, 2 by n square pi cos n pi, and this is for pi it will be 0, for 0 this will also be 0, so for 0 this is also 0. So this is the result, and we can write cos n pi as minus 1 to the power n. So it will be 4 by pi is cancelling out, so 4 by n square, 4 by n square minus 1 to the power n. So the value of n is minus 1 to the power n. Okay. Now if we want to find bn, we see that the formula bn is 1 by pi 0 minus pi to pi sine x square sine nx dx. Now since x square is an even function and sine is an odd function, so product of these two functions will be an odd function, and if we want to integrate this will be 0. Okay, so we got the value of a0 and a. Now we will write the Fourier series. So fx satisfies Dirichlet's conditions, hence a0 is 2 pi square by 3. So fx, that is x square. So since fx satisfies Dirichlet's condition, fx will converge, the Fourier series will converge to fx, that is x square. So x square equal to a0 by 2. So a0 is 2 pi square by 3, so this will be pi square by 3 plus summation n equal to 1 to infinity an. N means 4 by n square minus 1 to the power n, an cos nx. So this is our required Fourier series corresponding to the given function defined on the given interval. Now we have to find the value of some series. First we write the series. Number 1 plus 1 by 2 square plus 1 by 3 square plus dot dot dot. Number 2 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus dot. And number 3 1 plus 1 by 3 square plus 1 by 5 square plus dot dot dot. Now if we put x equal to 0 on the both sides, then it will be 0 equal to pi square by 3 plus summation n equal to 1 to infinity 4 by n square minus 1 to the power n. Okay. Now expanding this series, we get minus pi square by 3 equal to 4 is common, so minus 1 by 1 square For n equal to 2, this will be plus 1 by 2 square. For n equal to 3, this will be minus 1 by 3 square plus dot dot dot. In this way it will continue. Now okay, so the first, so we got, I think we got the second series. So if we take common minus, then it will be cancelled out from the both sides. So this will be pi square by 12. Pi square by 12 is 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus dot dot dot. This is the series number 2, and the value of the series is pi square by 12. Okay, putting x equal to 0, we got this. Now if we put x equal to pi, we put x equal to pi, no, okay, x equal to pi we are putting, then this will be pi square equal to pi square by 3 plus summation n equal to 1 to infinity 4 by n square minus 1 to the power n, and then cos n pi, cos n pi, and that is pi, okay, pi square by 3 is transferred to left hand side, so this will be 2 pi square by 3 equal to n equal to 1 to infinity and 4 by n square minus 1 to the power n into cos n pi is also minus 1 to the power n, so this will be n summation n equal to 1 to infinity 4 by n square minus 1 to the power 2n. Okay, so this will be plus 1. Now if we expand this series, this will be for n equal to 1, this will 4 is common, so 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus up to infinity. So 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus up to infinity, this will be equal to pi square by 4 is 4 is being divided, so this will be pi square by 6. So this is the answer of series number 1. So this is equal to pi square by 6. So we got the values of series number 1 and series number 2. Now we want the series number 3. Now to get series number 3, putting any value of x, you will not get series number 3. If you look at series number 1 and series number 2 carefully, then you can see that from series number 1 and series number 2 you can obtain series number 3. So if we add series number 1 and series number 2, adding 1 and 2, you will get 2 plus, okay, 1 by 2 square will be cancelled out, 1 by 4 square will be cancelled out, so even the terms with even integers will be, square of even integers will be cancelled out. So 2 by 3 square, 2 by 3 square, this is 2 by 1 square, 2 by 3 square, 2 by 5 square plus 2 by 7 square, like this. This is equal to pi square by 6 plus pi square by 12. Okay, this is equal to sign. So 2 is common, so 2 into 1 by 1 square plus 1 by 3 square plus 1 by 5 square 1 by 7 square plus dot equal to 12. 2 pi square plus pi square, that is 3 pi square. Okay, now you can see that series number 3 has been obtained. So 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus up to infinity. So 3 pi square by 24, that is pi square by 8. So this, the value of the series number 3 is pi square by 8. So after finding any Fourier series, we can find the values of infinite series like this, putting the values of x. So in this way we have to find Fourier series, applying the definitions of Fourier series and Fourier constants. So In the next video I will solve more problems of Fourier series. Please watch this video. If you have any query and any problem, then please contact with me. My contact details is given at the first slide of this video. Thank you.